I work for Folkefinans, and we are occupied in finance business too. With different kind of finance business. We are in loan business and credit card business. And my today's talk is about AWS Lambdas and what they are and why you should or should not care about them. Initially, what Lambda is, it is just a piece of code inside of AWS Cloud that you can fire in response to events without having to provision and manage the resources or like any kind of resources for it, including monitoring, logging, and all that kind of stuff. Just put some piece of code there, and it's already available for running. Initially, it is just a function that might take in or can take in some payload, and then you can execute some business logic there, and then make a decision either this execution was successful or not. Does anybody in audience
is anybody in audience using AWS services? Okay, quite a lot. Have anybody heard of Lambdas before? Maybe somebody's using Lambdas already. Okay, there is one guy. Cool. So as for now, they support 3 runtimes. It's Node.js version 0.10.30 something, then Python, and Java 8 too. And it's really easy to access this Lambda function and execute it. You can do it either from your own application directly using AWS SDK of your language of choice. Here's a Ruby example. Is like really straightforward. It's just instantiate a Lambda client with credentials and region, and just call invoke function or call invoke method on a Lambda client, passing function name. That's the only required argument, and a payload. Probably most of the cases you want to pass in a payload too, and that's it. And then you get a response whether or not your execution was successful. And of course, it has also great integration with other AWS tools available. And normally, most of the cases you want to run it in response to something that happens inside of your AWS cloud. Like here's an example of us using API Gateway that also is the Amazon's product. Then you receive some method call to an endpoint, map the request using mapping template, and then fire a Lambda function here, and then map the response and respond with your logic execution results. Easy as that, or simple as that. Or another example, we have an SNS topic. It's a simple notification service in AWS, and we have a Lambda function subscribed for this topic. So every time something gets published to this topic, Lambda picks it up and processes, and then succeeds or fails the context. And that's it. So Question to the audience. Any ideas how would you use it? How would you like to use it? Or you mentioned that you use Lambdas already. If it's not a secret, how do you use it? So what do you do with the Lambda?
Parsing emails.
Okay, so you're probably from Pipedrive, right?
Yes.
Okay, I attended to CodeShip's webinar where Tyre was talking about mentioning this how you parse emails, and he also mentioned that you managed to cut down the costs a great deal on this one with parsing emails, right?
Yes.
Cool stuff. Any more ideas how it's like possible to use in terms of your business domain? Okay, I will provide some really generic example. You can actually bootstrap any type of microservice with this one really easy. You don't have to provision anything. You just anything that any tiny application that does one single thing, like for example parsing emails. You just wrap the code inside of this handler, a function of a Lambda, put it out there, and voila, you already have it running, and then you can interact with it over HTTP or any other protocol too. So I can tell you about how we use it in Folkefinans. We mostly utilize Lambda opportunities for doing all kind of stuff with SMS messages. We operate we mostly operate on Swedish and Norwegian markets, and SMS one-time passcode is a way to authenticate a customer for us. So in order to sign in a customer, we send them an SMS with a generated one-time passcode. They enter it to the form, and then they're in. And we use their phone number as an identifier. And we deliver the SMS messages or dispatch the SMS messages to messaging provider with a Lambda. Then we collect SMS status updates, aka delivery reports, also with another Lambda. And we also receive incoming SMSs from customers, also with a Lambda. So for example, how does SMS delivery works? We also use an SNS topic for that. So anytime we want to publish or dispatch an SMS message, we publish it to a provider-specific SNS queue, or like notification service, sorry, not queue, but topic, notification service topic. And for example, to Twilio. And then corresponding Lambda function picks it up and dispatches it to Twilio, writes down some logs or whatever, and then returns us a message ID. And then with this message ID, Twilio, each time the message status gets updated, for example, first it was like in queued, then it was sent out, and then it was finally delivered. Each time the status change occurs, Twilio posts us a message status update call to our API gateway, which also gets picked up by another Lambda, and this Lambda maps the input, normalizes it from all the providers, and puts it to a status update SNS topic. And then you can consume it either directly by your application via HTTP, or if your application doesn't expose any HTTP endpoint, then you can use another tools. Like for example, some of our application use Amazon SQS queue service. And then this is pretty much how it happens. So if you get curious about it and you want to get started, then it's like extremely easy to get started. If you go to AWS Web Console and open Lambdas, there's like a bunch create new Lambda. You choose from a list of available templates, or this is one of the available templates. This is something with processes, as you can see, and or you write your own from scratch, and that's it. You just save it, and it's already there, available, and you can run it the way you want to run it. But this is like it helps you to get up and running like really quickly. But generally doing exactly like this is a bad idea, because you have really weak control over your code and what is exactly running out there. And it's like definitely not a production way of doing things. One step ahead is that you, for example, put your code in repository, then you version it, do something like have some a bit better idea about what is exactly you are deploying, and deploy with AWS CLI, for example, and call update function code, and then pass in function name and a zip file. And this way you at least prevent this function to be edited in online editor. Also, this way you can have your code to be broken down in multiple files, because if once your business logic for Lambda gets a little bit complex, then well, you will be instantly having this big pile of spaghetti inside of one file. So you want to break it down at least like somehow. But this is still like really a noob way to deliver your code to production like-ish environment, right? So of course, like any type of continuous delivery will also work here. As we mostly on Docker in Folkefinans, we use Worker for building our code, testing it in Docker, and then deploying it to our environments. But if you don't use Docker and you're interested in applying the bare minimum effort in having decent CI in place, then probably CodeShip is really good way to go. Well, so talking about some benefits I bought and I like AWS Lambdas for is first that you can get it up and running like really fast. You have an idea, in 5 minutes you can actually test your proof of concept already out there, and this is absolutely amazing thing. And another cool thing is that you only pay for what you use. In comparison, for example, if you shipped your microservice to the cloud with some, I don't know, to Amazon Cloud with some EC2 machine, or even with some Docker container using ECS, then you still pay all the time while it's running, right? It's running idle, and then you're paying for that. But with Lambdas, you only pay for actual compute time. For example, if nothing is triggering your Lambda, then it's free for you. And this can get really cost efficient in certain cases. It's also sort of scalable. I'm sorry, guys, that I can see that it's a bit hard to read from the back seats, is it?
No, it's okay.
I can't fix it now. It's a bit too late, but I'm sorry for that. So it's sort of scalable. They say that it allows you to execute by default up to 100 processes in parallel per account, and this is considered to be enough for most cases. And if you want to go beyond that, if you really want it real bad, then it's still possible. You just submit a ticket to AWS support, and then they can increase this threshold. And of course, it has really good integration with other AWS tools. A couple examples of how you can fire it from API gateway or an SNS topic was like 2 examples. So there's more. For example, it has built-in logging support. Logs are aggregated in CloudWatch, and if you output to console log JSON stringified JavaScript objects, so you get this really nice formatted JSON, which you can query and search and create all kinds of alarms and triggers on that. CloudWatch comes with a built-in query language, which comes really handy. You don't have to do anything in order to achieve this. It's all in the box, and that's I think really nice. Also, you can have alarms. For example, if you have some business critical thing running out there, and you know that if nobody's calling it for some reason, like for a decent period of time, as here in this example, then probably something is fishy. Probably everybody's still calling it but cannot access it, so it's not getting invoked. And then you get alarm, and then you action accordingly. And there's some things, of course, to watch out. Also, it's really easy to break in production. I mean, like normally, if you prototype, you kind of like put it already like against some production events, and it's really easy to break because, well, if you do not set up proper delivery for that right away, then you just accidentally deploy something raw, and then you lose your latest stable thing, and you're pretty much screwed. You have to like dedicate some time to fix it, and while you fix it, it's causing damage to your business meanwhile. And especially if you like kind of new to it, then, well, at least to me, it seemed really fragile, and I got it burned like many times during my learning curve with it. It's running not really top-notch Node.js version, and if your business logic or if your code relies on some top-notch language opportunities or framework opportunities, then you will have to tolerate and consider this. AWS has some built-in versioning support for Lambdas, which I found really weird. Maybe that's just me, but I didn't like it at all. And how I got my way around that is just I like only use latest version in AWS environment, but I do my versioning like with Git flow in GitHub, and then use continuous delivery system for managing what's actually running in production and basically use the same delivery flow as if I was working with other normal application. Yes,
What
Pep?
were the specific problems with the versioning?
It's like if you accidentally deploy something, you cannot. It's not really easy to recover the latest, just previous version because it overrides the latest version. You have to send a command to create a new version explicitly beforehand before you deploy, and that was, you know, that didn't feel really natural to me, at least. Is it it? Yeah. So that's me. Thank you. Happy hacking. And maybe some questions. Somebody got, yes, please.
So you mentioned that when you sign up for Lambda, you specify a region, right?
Yeah.
Do the Lambda instances have different external IP address then?
Well, they actually can get exposed to HTTP via API gateway, for example, but before that they have their, like, Amazon's internal address, which is ARN, and this is like...
Is it always the same for different Lambda instances?
It's well, it's the same for like it's the same for Lambda function, but you cannot really like have good control over like instantiating in the Lambdas. You can't, as I know, like you can't really tell how much exactly, or you can't really have good control of how much exactly of Lambdas you are running of this given moment and like kill one or like spin up one more. You just, for example, if it listens to the queue, you just add some more stuff to the queue, and if it like has, for example, if it's idle, then it's like fires a process and then executes it. But well.
Yeah, well, maybe I can specify it.
Yeah.
For example, you send an SMS, right? And let's say the SMS API only accepts requests from one specific IP address.
Okay.
And you have these Lambda instances or Lambdas created dynamically, right? All these Lambdas of the same code share the same IP, so they can at least make the API call.
We had this issue with Mesente, but it turns out in the end that Lambda doesn't really own the knowledge about networking, so it kind of like automatically wires down to what is responsible for making HTTP calls in AWS, and the way we had around that is we just whitelisted asterisks and because we didn't see it as an issue. But probably, I don't know, really. Any more questions? Yeah, yes, please.
Okay, have you measured what kind of latencies you are having there from just pure Amazon infrastructure side?
We didn't run like real metrics with Lambdas right at launch and on like our production scale, which is, to be honest, fairly modest. We are like more than satisfied with the performance. We don't have issues, so we don't have to measure it. And overall with Amazon, for example, when we switched from, we run Ruby stack mostly. When we switched from Heroku to running Docker containers in Amazon ECS, then we noticed a significant performance boost, and latency dropped like really significantly. So I don't know how much, but things for us at least got fairly faster with AWS.
So, as I understood, if you have peaks of requests, it could be cheaper, yeah. But if I have constant requests and will it be more expensive to use Lambda than using own servers? Like, I don't know.
Well, it is really hard to measure by like plain cost of service, because if you host yourself, like really yourself, you kind of take responsibility for this service being available, and it includes some like iron costs and human time costs and the knowledge cost and that kind of stuff, which is really hard to compare. But for example, if you compare running Lambda with running some virtual machine in the cloud, which you pay a constant hour rate, for example, then it depends. If, for example, your instance receives requests all the time, then constant hour rate might be cheaper. But if you have significant amount of idle time, then with Lambda you only pay for active time, which is not idle. And then as a result, Lambda can become cheaper for you, I think. Pep?
When you add more layers of interaction in the system, there's more chances for things to break in a way you don't understand. How has your experience been? How often have you debug issues which you didn't really understand why those things fail?
Well, debugging lambdas is piece of cake. Testing them locally and running or simulating execution locally on your dev machine is really easy. There are some great tools. It's like really good. But debugging AWS, this API gateway, which receives some request and maps the biggest issues I had with mapping the raw x form URL encoded post request to JSON inside of AWS gateway, API gateway. That was like real hell, and that I didn't enjoy at all. And this mapping template, Amazon wants you to write it with Apache Velocity template language. I don't know if anybody heard of it. It seemed a bit weird to me. And if you get anything wrong with your mapping template, you test your API endpoint, and it says like, sorry, no go, and it doesn't tell you like what's wrong, and then you have to guess and learning curve can be like really long. But in general, I think adding more moving parts is not worse than, in this particular case, is not worse than it's like can get normally worse. Because I mean, of course, adding more moving part like makes your system more fragile. But this particular case doesn't make you like any more fragile than it would be like naturally. Was one question here, please?
I don't understand. Like you are like sending this stuff with a circle, but not straight to the consumer. Why is this Lambda even needed?
You mean like SMS?
No, like you send something from one point to another point, but you are introducing this circle, this Lambda.
Well, with Lambda you can enqueue it. One thing you just send like some synchronous thing one time directly. First, with Lambda you make it asynchronous. Second, if you want to batch send, I don't know, gazillion of messages at a time, then you can use Lambda as a background job. You have a dedicated service that does one thing, delivers messages, for example. So that's it. You just hand it off, and it knows the best how exactly does it do it. So this is the main reason you do it.
One question regarding the use cases of Lambda. So I see like very good to use for like this a dedicated microservice which processes something. Is it can it be somehow used like, imagine I'm at a hackathon, I have a I don't know classic MVC application. Can I use Lambda somehow effectively for that? Just to deploy
to do the background jobs for your application. For example, when you sign up a customer, Then you send them email, you send them a gift, and then you send them something else, and you like do like multiple action, and then instead of doing it like inside of your like MVC application, just offload it to the background, and Lambda can be one way to implement your background job tool. Or for example, if your like hackathon project, your prototype is not a product in its classic way, it doesn't like have this landing page and then this like some user value. It's, for example, let's say it's a prototype of an algorithm. Then you can demo it how it runs in Lambda. Then it can be maybe like a good fit. Yes.
How big files can I upload there? So like, can I process a movie there?
5-minute use case. If you can't handle it in 5 minutes.
Yeah, normally you would pass some JSON data there. Some like data type of data. For movies, there's probably like better tools, much better than that. Okay then, thanks a lot. We will probably now have a tour, will we?
I'll take over.
Yeah, okay.